Hi everyone, welcome to Lecture 7 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. Today we'll be discussing about molecular formula and empirical formula. So we'll start with molecular formula. So what is molecular formula? Molecular formula is a type of chemical formula. It tells us exactly how many atoms of each element are present in a compound. For example, here, this is the structure of ethane, and this is the molecular formula of ethane. So the molecular formula of ethane is C2H6. So looking at this molecular formula, you can see that there are two carbon atoms and there are 6 hydrogen atoms, as you can see here in the structure. So this is the molecular formula for this compound. So it tells us there are 5 carbon atoms and there are 12 hydrogen atoms. So molecular formula always tells us how many atoms of each element are in a compound. So let's now look at empirical formula. What is empirical formula? So when the number of atoms in a compound is in the most reduced ratio, we call that formula empirical formula. So when the number of atoms in a compound is in the most reduced ratio, we call that formula empirical formula. So empirical formula does not show the total number of atoms in the molecule like molecular formula. It simply shows the number of atoms in the most reduced ratio. So let's have a look on how to write empirical formula from molecular formula. Now that we know the meaning of molecular formula, it tells us the total number of atoms of each element in a compound. And we also know the meaning of empirical formula. It gives us the most reduced ratio of atoms in a compound. Let us look at this example. So, the molecular formula for butane is C4H10. This is the structure. You can see it has 4 carbons and 10 hydrogen atoms. So how do we write the empirical formula from this molecular formula? We look at the subscripts. So here we have 4 and for hydrogen we have 10. What is the highest number that can divide both? The highest number that can divide 4 and 10 is 2. So for 4 carbon atoms, we divide by 2, we will get 2 carbons. And for 10 hydrogen atoms, we divide by 2 and we get 5. Therefore, the empirical formula is C2H5 because here, when we divided by 2, we got 2 carbons. And here, when we divided by 2, we got 5 hydrogens. So the empirical formula of butane is C2H5. Let's look at another example. If you are asked to write the empirical formula of ethane, the molecular formula for ethane is C8H18. So just like we did for butane, you find the highest number that can divide both subscripts. So the highest number that can divide 8 and 18 is 2. So if we divide C8 by 2, we will get 4 carbons. And if we divide 18 by 2, we will get 9 hydrogens. So the empirical formula for ethane is therefore C4H9 because when we divided 8 carbons by 2, we got 4. And when we divided 18 hydrogens by 2, we got 9 hydrogens. And the reason why we divided by 2 was because 2 is the highest number that can divide both 8 and 18. So the empirical formula always gives you the most reduced ratio of atoms in a compound, as you can see here, while the molecular formula will give you the total number of atoms of each element present in a compound. So just for you to test your knowledge, to know whether you've understood how to write empirical formula from molecular formula, you can try these examples and see whether you will get the empirical formula. So, what about when there are three elements in a compound? We have looked at examples where there are just two elements in a compound. So when there are three elements in a compound, how do you write the empirical formula? When there are three elements in a compound, as you can see here, C6H12O6, so there are three different elements, carbon, hydrogen, and oxygen. How would you write the empirical formula from this molecular formula? We simply do what we did when we had just two elements in a compound. So we find the highest number that can divide all subscripts. So we have 6, 12, 6. What is the highest number that can divide all subscripts? That number is 6. So if we divide C6 by 6, we'll get C because it will be just 1. And when we divide 12 by 6, we will get H2. When we divide 6 by 6, we'll just get one oxygen atom. So we simply write O to represent for the oxygen. So then the empirical formula is then CH2O. Some molecular formula cannot be simplified further. Let's have a look on these examples, P3 and 5. If you look at both subscripts 3 and 5, there is no number that can divide both subscripts. So in that case, the empirical formula of P3 and 5 is same as the molecular formula. So it will still be P3 and 5. For C12H22O11, you can see again there is no number that can divide 12, 22, and 11. So in that case, the empirical formula of C12H22O11 will still be C12H22O11. If you look at this compound C5H12, there is no number that can divide both 5 and 12. Therefore, the empirical formula of C5H12 is also C5H12 because you cannot simplify the ratio of atoms any further. Right, many different compounds can all have the same empirical formula. Let's have a look on these examples. So these 5 compounds, even though different, all have the same empirical formula. So for C2H4, the subscripts are 2 and 4, and the highest number that can divide both 2 and 4 is 2. So the empirical formula for C2H4 is CH2. For C3H6, the highest number that can divide both 3 and 6 is 3. So the empirical formula for C3H6 is CH2. For C4H8, the highest number that can divide both 4 and 8 is 4. So the empirical formula for C4H8 is CH2. For C6H12, the highest number that can divide both 6 and 12 is 6. So the empirical formula for C6H12 is CH2. So all these different compounds have the same empirical formula. So just for you to test your knowledge again, you try to write the empirical formula of these different compounds just to familiarize yourself on how to write empirical formula when you are given the molecular formula. So this is where I'm gonna end today's video. Please like this video and subscribe, and I'm gonna see you in the next lecture.